Unit 8, Lesson 1, Properties of Logarithms, and this is Part 2. We're going to start by reviewing 3 different expressions and looking at how we can rewrite each of these expressions. When we rewrite each of these expressions, we are going to rely on the 3 separate properties of logs that we spoke about in the first video of this lesson. Okay, let's get started. How can we expand each of these expressions? So when I look here, I'm looking at some quantity divided by another quantity. So I know I want to rewrite this and expand it by turning division into subtraction. Log base 5 of x to the third, division turns to subtraction, and log base 5 of y squared times the square root of z. Now I can continue to expand here using a few different properties. Remember, whenever we have an exponent, it's going to drop directly in front. So 3 times log base 5 of x. And in the past, I do remember that some students feel more confident putting brackets or parentheses around both the numerator and the denominator. So there's my numerator, and now I'm going to work on the denominator in back. These 2 quantities are multiplied, and so when I expand it, multiplication is going to turn into addition. Log base 5 of y squared plus log base 5 of the square root of z. Now, real quick, the square root can also be written, so the square root of z is equivalent in exponential form as z to the 1/2. So I have 3 log base 5 of x, and again, if you want to put brackets or parentheses, feel free to do that. This is especially important that you put parentheses around unless you decide to distribute that. Let me show you an example. So I have log base 5 of y, but this square is going to go in front. And then over here, again, this 1/2, I'm going to rewrite that as z to the 1/2. The 1/2 is going to go in front. And my very last job here is going to be to distribute this negative to both the first and the second term. So my final expanded form of this original expression is 3 log base 5 of x, subtract 2 log base 5 of y, subtract 1/2 log base 5 of z, equivalent to the original expression. All right, let's look at the next one. So now I'm looking right now at natural log. Remember, that's equivalent to log base e. So if I make a little line here to separate this, I'm going to rewrite this right away as the ln of x divided by y, z to the third. And another way to rewrite this, remember the nth root is 2, it would be 1/2. So the first thing I'm going to do is I'm going to take this exponent and I'm going to put it in front. So I have 1/2 the ln of x over y, z to the third. Now, as I expand this, remember that division, just like we did in the first example, is going to turn into addition. So I have 1/2. Now that 1/2 is eventually going to have to be distributed to everything behind it, and it's going to be the ln of x, subtract, okay, now I have 2 items here, subtract the ln of y, z to the third. I'm going to switch colors here so we can just see the differentiated forms. I have 1/2 the ln of x, subtract, and now I'm going to expand this. So ln of y, multiplication turns to addition when we expand, and the ln of z. And I'm going to take this exponent and I'm going to throw it in front. Okay, next I'm going to take this subtraction and distribute it to both terms behind. So I have 1/2 ln of x minus the ln of y minus 3 ln of z. And then my very last step is going to be to take that 1/2 and to distribute to all 3 terms. 1/2 ln of x minus 1/2 ln of y. Now what's half of 3? Well, we can multiply. 1 times 3 is 3. 2 times 1 is 2, so we have 3 halves, or 1.5 ln of z. Let's look at our third example. In our third example, right away I recognize this trinomial. And I recognize that I can factor this. What multiplies to equal 25 and combines to give us negative 10? That would be negative 5 and negative 5. So I can rewrite this expression as log base 7 of x minus 5 times x minus 5. And we learned in 8th and 9th grade when we have the same quantity twice being multiplied, we can rewrite it as x minus 5 quantity squared. Okay, that property of logs allows us to take this exponent and drop it in front. 2 times log base 7 of x minus 5. I'd like you to press pause on this video as you're watching this. I want you to try this 4th example and then come back to see if your answer matches mine. Good luck. Similar to the second example here, I'm going to rewrite this. Natural log of x to the 5th y divided by z squared. And this is the nth root of 3. So when I rewrite it in exponential form, it's raised to the 1/3 power. So the first thing I'm going to do is I'm going to drop that 1/3 in front. So 1/3 times the ln of x to the 5th y over z squared. And now it's time to expand. Let me switch colors so we can differentiate between each step here. So I have 1/3, and I need to multiply that by the ln. Now I'm going to, hopefully you're catching on to this, I'm going to take time right now to expand these two. So ln of x, and this 5, which is an exponent, is going to go in front. Multiplication when we expand terms to addition, times the ln of y. So there's the numerator, division turns to subtraction, and then I have the ln of z squared. The squared is going to go in front. Now when I distribute that subtraction sign, there's only one thing it's distributing to. So I have 1/3, 5 ln of x plus ln of y, subtract 2 ln of z. And now it's time to distribute the 1/3 to all three terms. So 1 times 5 is 5. 3 times 1 is 3. So I have 5/3 ln of x plus 1/3 times 1 is 1/3 ln of y. 1/3 times negative 2. 1 times negative 2 is negative 2. 3 times 1 is 3 ln of z.